In this video, I want to go back and look at integrating a derivative and what that means in terms of an actual finding the function. So we know if we integrate a derivative, we'll get back to the original function. So if we find the derivative of p, then it's p dashed of x. That should be p of x. And so if we integrate this side and integrate this side, we should get the same thing. So I'm going to integrate this side here, but I'm going to put two terminal points on it, a and b. So I get the integral of my original thing, which should say p of x, dx here. When I integrate the derivative, I get p out, and then I should substitute in b, and then take away a substituted in. And what you actually get here are the two y values, if you like, for points b, x equals b, and x equals a. So let me say that again. What you're actually getting, this p of b, is the y value of the original function, p of b. And this p of a is the y value of the original function when x is equal to a in here. So what you're actually finding when you find the definite integral for a derivative is you're actually finding the difference between, so p of b minus p of b minus p of a is actually this difference here. And we would describe that difference as the change in p between a and b. So let's have a look at this in a little bit more detail. Let's do that using this example. So the rate at which the number of bacterium in a Petri dish increases is given by the formula dn dt equals e to the t, where t is the number of hours since the bacterium were first placed into the Petri dish, and n obviously is the number of bacteria. I forgot to write that. So we've got a derivative formula here. The question then goes on to say, what is the change in the number of bacterium between t equals 2 and t equals 4 as an exact value and correct to 2 decimal places? So what we're going to do is we're going to use this relationship that if we find the derivative of n with respect to t, we get e to the 2t. Because we know, it says up here, our derivative is e to the 2t. So I'm going to integrate both sides, and we're going to go for our terminals from 2 hours, t equals 2 and t equals 4. So t equals 2 to t equals 4. When we do that integration of that derivative, that's equivalent as if we integrated the other side of this equation between 2 and 4. And so what that does is it gives us our n of 4 minus n of 2, which is the change in the number of bacterium between t equals 4 and t equals 2. So when we're solving this question, this is the thought process behind what we're about to do. What we actually do just starts here. So what we actually write just starts here. So the rest of this here is our thinking. So what we actually do is we just integrate that derivative between 2 and 4, knowing that it's going to give us the particular answer that we're looking for, which is the change between the second hour and the fourth hour. And the answers were asked as exact values, which is what you've got here. You may like to take the common factor of a half out, not important unless they tell you that it needs to be in a particular form. So in the exam, any equivalent form that is correct is acceptable. And then finally, we also had to do the calculation to a particular number of decimal places. So let's just go back and see what that was. It was to 2 decimal places. And so we'll use our CAS calculator to do that. And when we do, we get 1463 and some other decimal places. That when we round it to 2 decimal places becomes 1463. So in summary, when we integrate a derivative with an indefinite integral, what we get is the formula for the function plus c. But if we've got a definite integral with endpoints, what we actually get out is the difference between f of b and f of a. We get this difference here, which is in the change in the quantity that we're measuring on this axis over this time period or whatever it is that we're measuring here. So the sorts of questions that you'll get is given dv dt, a function for dv dt, find the total volume change in the first 10 hours. So you would integrate this formula between 0 and 10. This one here, dt is x plus 3. Find the total temperature change. So this T is for temperature change between 2 a.m. and 5 a.m. So you would integrate this particular function between whatever the T values were for 2 a.m. and 5 a.m. And if you are working with questions like this where it is time, always check what is that T equals what. Is it actually 2 or is it actually 5 or is it something else?